at EclipseCon and welcome to my talk about data-centric editors for domain experts with EMF Forms. I'm Jonas, I work for Eclipse. We are a company building tools for our customers, or we help our customers to build tools. And a lot of those tools are data-centric, that's how we call it. Those tools basically support engineers in describing some domain-specific things. And there are actually different ways to represent that typically in a tool. One would be graphical with diagrams. One would be textual with a programming language or a DSL. And the third, and that's what I want to talk about today, is data-centric or form-based. And that means we have a form where you can enter data. We have trees and tables and all this stuff. And it is actually surprising for us to see how much is actually done in the third representation. Like the first is graphical is good for stuff like behavior and structure, maybe references. Second one is also good for behavior and if you have a very focused use case, while this form-based is just for the masses. So if you have any domain-specific problem, in a lot of domains you need to enter a lot of data, you want to validate this data, and people basically describe things. And today my talk will be focused on how to do the third form-based type of editor efficiently with a framework called EMF Forms. 2 comments about my talk. So EMF Forms has been there for quite a while now, so we believe it's very feature-rich. What I want to do today is, rather than showing you hundreds and hundreds of slides, I would like to do a lot of demonstrations. And I will actually walk through a typical scenario how a project might use EMF Forms and present you feature by feature, like this is there, this is how you can use it, and then the next feature, and then the next feature. If you're interested in the technical details, all the stuff that I show you today is available open source, and there's also documentation for every of those features. And you can also just talk to me or anybody from Eclipse source or another contributor if you want to learn more details about that. And the second comment, the demo that I showed today is desktop-based, so it's based on SWT and embedded in the Eclipse IDE, although there is an equivalent to that available for the web, which I will show at the very end. But it works almost similar. Okay. Before we dive into the feature demo, I want to give a very quick introduction on the approach. Quick question, who of you has used EMF Forms before? 1, okay, that's 2, that's perfect. So the basic idea is engineering data is, as I just mentioned, besides graphical representation and textual representation, it's often represented and edited in form-based UIs. And those can become amazingly complex and large, and you will really have a lot of forms and so on. And you can have them on the desktop, and the web, or even on mobile devices to enter something from, I don't know, a storage department or whatever. Now, if we look at the problem of coding a form, it is actually surprising how much effort that is in practice. Now, let's look at the simplest form we can imagine. One entry field to enter the first name, a label, and a text box. How much code is that in SWT? If you do it right, it's actually this code. It's creating those 2 elements, it's creating a layout, it's creating a data binding, and it is wiring the validation. So this is the code you need to write for only one text field. Now, you might argue, and that's actually true, if you write a second text field, hopefully you can extract this code, because this thing that is different is actually which attribute to bind to and what is the label. So hopefully you can extract that so you don't have to write this code again for the second text field. However, if we think about a slightly more complex form with 4 attributes, you have to repeat this process for other attribute types, like for example, a dropdown for an enum, a checkbox for a boolean, and now the layout comes in place. And the layout for the form on the left side looks like this. So it's really a lot of code. And as you can see from the structure, this code is not intended to be readable by you from a size point of view. But if you look at the structure, it's really recurring. It's always the same. And whenever you have a lot of code for a very simple problem, it's typically a sign that there might be some opportunity for for a declarative approach, meaning describing what you want to do more efficiently in a declarative artifact. And that's exactly the idea of EMF Forms. So instead of writing all this code, what EMF Forms provides you with is a very simple declarative language in which you can describe a form like this. So, and you just provide the necessary information, which is there is a control for the attribute first name. And the framework now can take care, okay, I need a label, I need a text box, the label is first name, I need to bind the text box to the attribute first name, and I need to wire the validation. This is all recurring. We just need to know, okay, we want to look at first name. And the same if we transfer that to the next example where we just have a simple layout of 4 controls in a row. In EMF Forms, that looks like this. Of course, those declarative artifacts become a little bit more complex if we add layout, but they still are much simpler compared to code, and we will see that during the demonstration. Now we see how forms are actually described in EMF Forms. Now the question is, what do we do with this declarative artifact? I mean, at the end, we want to have a form in our application that the user can use. So where is this coming from? There's one piece missing. So this is the full story. To use EMF Forms, you have the underlying data model. That's actually your data that you want to edit, and you could provide that as an eCore, as an XSD, or as POJOS, or however you want. Then we have this description of the UI. This artifact is called a view model in EMF Forms. So this is a declarative artifact describing the structure of your UI. And then during runtime, there is a component that we call the renderer. That is actually a component written in SWT, and this component translates the declarative description of the UI into a real UI that the user can see on screen. So we interpret the declarative description. If you think about that, it's very similar, for example, to how browsers work. So you have the declarative HTML description, and the browser just transfers that to something random. And we do the same, but we are focused on forms, so our declarative description is focused in making it very efficient to describe form-based UIs. Now, I will now dive into my demo. For my demo, I will use an example model. This example model is actually part of every Eclipse modeling instance, so you can use it yourself. It is from the engineering domain, and the example model can be used to describe coffee machines. So the idea is there are engineers at a coffee machine vendor, and they have a tool where they can describe new models and can enter all the data. So the model is actually quite big. I want to focus on 3 entities, just for the sake of simplicity. Part of this model, there is an element called control unit, which is part of a coffee machine, and that's actually the unit which controls some behavior of this coffee machine. And this control unit has a sub-element called processor. Processor has a couple of attributes like vendor, clock speed, number of cores, and so on. And it has a list of RAMs, so you can put an arbitrary number of RAMs into a control unit. So it's a classic configuration case. It doesn't necessarily make sense. It's meant as an example. However, we have, like, if we look at our customer projects and adopter projects of EMF Forms, they often do something very similar, like in different domains. They have an existing model and they use EMF Forms to build a tool to configure concrete products with it. Okay. So how to get started? What I want to show now is I want to start with the processor artifact. So it's actually too far. This room is too big. I cannot even point there. I want to create a first form just for the entity processor in which the user can enter the data about one processor. So let me switch to my IDE. What I have prepared in my workspace is the model. That's the data model. And this describes the underlying data. So let me quickly open that. That's called coffee model. And in here you find quite a few entities. And for example, we find here the processor with all the attributes already defined. Typically, in a development scenario, this would, most of the time, this is already there because there's, for example, some data format in which another department expects the configuration data. So you could derive this from an XSD, for example. Now let's create a form for the processor. What I can actually do, and everything that I show now is available in a standard Eclipse modeling edition. So everything is available. Now what I can do is I can right click here on this eco file, select EMF Forms, and then say create view model. Now this shows me all the entities in this ecore, and I can select for which entity I would like to create a form. In my case, that's processor. Down here, I can select whether the view model should be filled with a default layout. A default layout always means all attributes are there in a row. Very simple way to get started. And now I just select the place where I want to put this. I have already created a project for that. And now I can click on Finish. And now we see an editor opening up. That's the view model editor. It's also a hierarchical editor. We are not aiming at a drag and drop editor, or what you see is what you get editor. You will see in a second why. Now, as you can see, this contains all the controls in a declarative description. However, this is quite abstract. If I want to work with this, I actually want to see how this looks in practice. So what I can do is I can open the preview down here, and here I see my form. So this is what you get out of the box. So you see there is a field for every attribute where you can enter the data. It actually automatically selects the right control per type. So for example, this is an enumeration where I can specify some types. Here I have a number field, and here I have a field for the vendor. Now the control flow is whenever I change something on top, I can update the preview. I can also make the preview just update on every change. Now, as we can see, this is a very simple layout at the moment. It just is a flat list of controls, and it doesn't look very nice. So let's create a structure. Let's create a layout for that. So to do that, I can add new elements to this tree. So for example, I could add a group and give the group a title, my group. And then I can just move all those elements via drag and drop in here, and then save this, and now I have a group down here. Or for example, if I want to have 2 columns, I could create a horizontal layout in here and 2 verticals, just like this. And then for example, I could move the first 3 in the first column and the second 3 in the second column, save this. Boom, now we have a much more readable layout. Now, if you compare that with the effort of using a grid layout in SWT, you might agree that this is much more efficient. And the reason why this works so well is that we really have a clear focus on forms. That's why the rendering and the layout and all the stuff, we can make some assumptions, but in turn, we can make it much easier to maintain and create those forms. Another interesting point is what happens if you change the underlying domain model. Like for example, what happens if you add a new attribute, which is a typical case, especially in the beginning of a project. So let's simulate that. I will not do that in the eCore now, because I think you can imagine like adding a new attribute. What I will do is I will remove the control here to simulate, okay, now this control is missing because it was added in the model. So let's save that. So what I can actually do is I can right click here, and there is an option to generate controls. What this will do is it will look again at the data model and see, look at all the attributes which are there in the data model, and I could just check them. And it can even compare that with the view model. So I can click here to only show me the attributes which are not yet part of the form. Looks like a very trivial feature, but if you have like complex forms, this is actually incredibly useful, because you know exactly, okay, this is missing, I have to place this. So I just add this, and now I have the form completed again. All right, so that's basically how to get started. It's worth mentioning, so I've showed group, horizontal layout, and vertical layout. There are a couple of additional elements like tables, stacks, tab layouts, and so on. However, the list is not indefinitely long. So we are focused on the set that you typically need for forms, and from our experience, in recent years, this list doesn't grow anymore. Like new users, they typically find what they need. I mean, there are not like too many concepts that you use in those form-based UIs. So we would say it's kind of complete. Okay, so let's move on to the next example. Now, if we look at the the part of the data model that I'm focusing on today. Currently I've only covered the processor, but let's assume I would now like to create a form for the control unit. Now the control unit has two specialities. Actually, the processor is contained in the control unit, and every control unit has exactly one processor. So this happens often in models, and what you typically actually want to do is not create a dedicated UI for the processor, but you just want to embed the processor UI into the control unit UI, so that if I open the control unit, I see the attributes of the processor. So that is supported. We can actually traverse references. And the other case is for the RAM. That's a list of RAMs. So I want to have some list item, and I will show you in a second how to create a table for the RAM attribute. All right, so we talk about hierarchies and tables. For that, what I prepared is a view model for the control unit, just to not bore you with exactly the same operation. And what we can see here, I did exactly the same as I did before for the processor. So here the attributes of the processor are actually embedded into the control unit UI, and what you can see here, it shows me the path. This actually points to the data model. So it goes from control unit to the processor, and then from processor to the attribute vendor. And that's why I can actually embed an attribute of the processor into the control unit UI. Now the second feature I wanted to show is a table control. So I want to show the RAMs of a processor here. For that, I will use another element called table control. Now, for a table control, I need to configure where do the elements shown in the table come from, like from which reference. And I can do that in this wizard. Now, this shows me the references, or more precisely, the attributes of the control unit, and there is a multi-reference for RAM. So this way, I tell the table, please show me all elements in this list, in this multi-reference. I can click OK. And now the table is basically there, but it doesn't have any columns. And to solve that, what I can do is I can right-click and select Generate Columns. This will again look at the data model, and it will create for every attribute of the RAM type, it will create a column, and you can see that here that's clock speed, size, and type. And now finally, let me change the layout here a bit. I don't know whether that's correct now. Let's save this. Yeah, so now we have here the table that I just created with the columns clock, speed, size, type. I can create new elements. I can enter something here, like, I don't know, the size. I can create another element. I have features like copy, paste, everything you would expect from a table. And this was basically just a few clicks. So again, if you have ever manually implemented such a table in SWT, you might see the power of this approach, because we basically just reduce it to the necessary configuration we need. Obviously, we can only cover, or we can only provide some defaults. Like, for example, if you have very special cell editors in such a table, EMF Forms cannot solve any specific problem for you. However, the framework is very extensible. So for example, if you have a very custom cell editor, you can easily plug that into that table and thereby extend the default. And that's completely foreseen that users will do that. All right, so that's it about table. So now we have looked a lot at the view model and this preview feature down there, but you might now wonder, okay, this is cool, now I have the form in my IDE, but at the end you want it in your application. So how to embed this into your application. I would show you two examples how to do that. One is I created a very simple example application here. This example application literally it contains exactly one part. And this part has this method here. You can actually ignore this. This is just creating a frame. The interesting line of code is this. This is a call to EMF Forms, which says, renderer, SWT renderer, please render an input object that I create over here on this composite. So it's literally one line of code, and you can embed EMF Forms at any place in your application. So let's simply start that. And this is how the application looks like, one part. We have the table here, we have the elements here with validation, we can select stuff. Here down here we have a multi-line field, like everything how you would expect. And you can place that at any place in your application, in a dialog, in a part, wherever you want. The second way of embedding I want to show is the EMF Forms also provides a ready-to-use editor, which is often used if the tool you're developing is kind of part of a bigger tool, like for example, you want to embed it into the IDE or another Eclipse-based tool that you develop. For that, I can generate an editor based on the gen model. So let me do that. So I select to generate the editor. And now you can see that, let me close all this. You can see that a new plugin was created over here. Let's move that over here. And this is pretty much like the generated editor you know from EMF. However, it's using EMF Forms, and it's actually meant to be extensible compared to the original editor. So let's just start that. Clear. So now you see I start a second full Eclipse instance. So this is a use case that you really base something on Eclipse. So you really develop a plugin. And now once this is started, let me create such a model file. The nice thing about this is you can rely on the existing infrastructure. So for example, you can just create a project. They have removed this. New, other, project, which is basically just a folder in my use case. And now I want to create a model file. So there are those wizard, or there's this wizard created by EMF actually. I mean, you could provide your own one, but this is fully generated, so it's a good default. And this is the generated editor that you know, but now I can open this with the EMF Forms editor, which looks like this. And you can see we have a tree on the left side, which allows to create elements, for example, the control unit. And now on the right side, we have the form that we just saw in our IDE. And again, it's fully functional. So we have validation, we have data binding. Like for example, if I enter here, the vendor is Eclipse source. There's actually a validation rule, that's why it's red. But if we then open this in a text editor, we see that here. So the whole stack already works. Good. What about validation? So I've mentioned that a few times. Actually, especially in engineering domains, validation is a huge topic. Like there are endless validation rules. That's why EMF Forms is, because so many customers were from that domain, EMF Forms is very extensible and has a lot of different ways to plug in validations. You can add your own service, you can extend it with your own framework, how validation rules are evaluated. What I want to show is the default built-in way, or one default built-in way how to do that. Just to give you one impression. Actually, in my data model, I have defined a constrained data type that is called, the name doesn't make sense. Sorry for that. So this data type is a string, and it has a max length of 10, a min length of 0, and it defines two patterns. The idea behind that is in many fields you want to restrict the letters that somebody can input already to some set. Like for example, they cannot enter numbers, but they should be able to enter all letters. And then you often have a second pattern that you want to evaluate once the user is done with this evaluation. The reason for that is otherwise, for example, to enter an email address and to validate that, you cannot validate that on every keystroke, because then people would never be able to actually enter a valid email address. So this particular example allows uppercase and smaller case letters, but at the end it expects only uppercase. And now let's look at this, how this would then be evaluated by EMF Forms. So it's here, this field is constrained by this. So the first thing is, if I start to type, it will stop at 10. It will not allow me to enter more than 10, because, I mean, you have to believe me that I'm still pressing this key. And because it knows, okay, 10 is the maximum, and now the framework can already automatically add these constraints to the field. Of course, you can adapt that, but that's a pretty good default. If you program this stuff manually, this is really a lot of work. Now you see everything is fine. Now, if I add a small letter, it allows me to do so, but it shows me a validation error. Now, and finally, if I, how am I supposed to do that? So if I want to copy this, which is a character which is not even allowed, I cannot. It doesn't even allow me to paste that, because that was forbidden by the other pattern. This is the pattern which actually restricts the input already. So you have those two possibilities. And there's a lot of similar stuff in EMF Forms to support you with even complex validation rules. The idea is always you want to keep your validation logic out of your UI code, because that is really hard to maintain over the years, and validation is really part of your business logic, so it has some value in it. So whenever we can improve the way how you express your validation rules, that provides a lot of value. And by the way, those validation rules are then also applied, for example, in tables. So if we, for example, enter, it doesn't accept that because that's against the rules here. So in this table, the default behavior is that it doesn't accept input which doesn't validate, as an example. All right. How am I in time? So I have to speed up a little. Conditional visibility and enablement. Let me very quickly demonstrate that. That's often used in forms. So you want to have a condition like, if this is true, then this is not visible. So let me quickly add that. So for example, I only want to show the terminal design power based on what is selected for the connector type. So what I can actually do is I can add a rule, and I can add a condition to that. And this condition can now point to another attribute. So I can select here, okay, I want to connect this to processor socket type, just like this. And now if the socket type is, these are the values from the domain model, the two values of the enumeration. For example, if it's this, then I want to hide it. Now it's away, and now it's back. Again, if you program that manually, that can be a lot of work. How to customize controls and layouts. This is a very interesting question. It's important to understand that EMF only aims at providing a default set of controls, but it's very likely that you want to customize the look and feel somehow. And this is completely foreseen and possible. In fact, the renderer that I've described before, it's not one renderer, it's one renderer, at least one renderer per concept. So there's one renderer for a text box, one for dropdown, and so on. And you can even have several text box renderer and define condition like, when is a text box rendered like this, when it's rendered like this, and it's completely foreseen that you add your own renderers to completely modify how the UI looks like. Again, it's important to understand EMF Forms wants to provide a default because that gets you started very quickly, but you very likely will add your own renderers. Now, let me just show you an example for that. So currently we can see down here that the groups are just rendered with a line. Maybe you want to change that. So what I actually have over here is a custom renderer, and let's quickly look at that. This is how a renderer looks like. So you can see it's like 130 lines of code with spaces. And the interesting part is actually this here. This really creates the element. So it's not super complex to provide your own renderer. Here we actually create a P group instead of a regular group. What we do here is, this is expand listener, so we define the behavior, what happens if you collapse or expand that. So let me quickly show that. By the way, there are some customizations already doable without exchanging the renderer. For example, I could make this collapsible, like this. And then I already influenced the rendering, so there are some customizations. But what I can do is, if I really want to replace the renderer, I will add this, this custom renderer here to my run configuration, and then just restart the first application that you've seen. Oh, and here now you see the groups look completely different now because I plugged in my own renderer. And very similarly, you can plug in your own renderer for controls and thereby completely modify how this looks like. All right, and final question, what about the web? And the good news is there is an equivalent framework for EMF Forms in the web called JSON Forms. And you can even export artifacts from EMF Forms to JSON Forms. So what I can do is I can right-click here on my view model and say export to JSON Forms. And this will now convert my view model to a JSON format, which is then processed by the web equivalent called JSON Forms. And just that you get an impression how this looks like. Here I see Thea, an online IDE, and in this IDE I've embedded the same editor that I've just shown you in the Eclipse IDE, however as a web version. So let's open that. So you can see I have the tree here on the left side, and here is the control unit UI with the same layout, slightly looking different because the rendering is obviously different, but also the same in UI. And now I can still enter stuff. So there is a path, a migration path to, if you have an existing UI made with EMF Forms, you can very efficiently transform that to the web. I don't want to lie to you, it's not like a no-brainer, because for example, if you've written your own custom controls and custom renderers for groups, for example, those are obviously not just transferable to the web. Like those you have to redo. Although the good news is, I mean, those you only have to write once and then you can use them all in your application. And what you can preserve is the custom description of the logic of your UI, mainly the layout in form of the view model. Yeah, and the final question that we get very often is like, does EMF support this and that? So EMF Forms is really like, we recently released the release 1.22. So we did 22 releases without API breaks in a row, and we only added features, because every new project has some new requirements. So it's surprising. So for new projects, it's often surprising that they want something they think is very special, and we can then say, hey, no, we have this here. You can just reuse it and adapt it a bit. However, even if something is not supported by EMF Forms, it is an open source project. It's hosted at the Eclipse Foundation. You can use it for free, and you can adapt it. And we have built it in an extensible way from the beginning. So it has always been meant as a basis for your own solution. So almost everything in EMF Forms is conceptually adaptable. Plus, our goal is basically to help our customers with this framework. So in case you miss something, you can either fix that yourself, or you can also talk to us and we can support you in doing so. For example, get you started with EMF Forms or add an extension mechanism that you are actually missing. Yeah, and with that, I would like to conclude my talk. So I've mentioned the first thing. EMF Forms, although it has been out for quite a while, it's still very active because we have a lot of customers using that, which is good for the project. So maintenance is good. I think there's quite some documentation there. You find that on the website. If you're interested in news or new releases, we have a Twitter feed. And I'm happy to take any questions now. We also have a booth here and we're running around. So if you see someone with such a shirt, Eclipse source, and you have a question about EMF forms or JSON forms, feel free to talk to us about your use case, about your question or anything. Now, are there any questions right now? Too much features.